Hello everyone, this is demo for our project CodeSense for class EMGT308. Our team members include Vishwas, Manav and me, Sahaj. So let's start. So CodeSense is an agentic PR debugging pipeline, and here's a GitHub repo consisting of a project, and I have made a PR recently, and I want to check if this PR is correct or not. So what we do is we just tag CodeSense and CodeSense will invoke its agentic workflow and then check if the PR is correct or not. As you can see, we have gotten one running around here. So let's see. So we have three agents: hunter, coder and evaluator, and all of them are just making those intermediate output results. Hunter basically finds bugs in our code, coder gives the diff patch, and evaluator actually applies those patch in a sandbox running on cloud and then runs those tests and comes back with either a PR or a PR not required output. So let's get back over here and let's see. So as you can see, it says pass and evaluated. So let's go on to the draft PR, and you can see it's in the same project and a new PR has come up. It's in draft mode, and let's see what changes it made. So it actually rectified A plus B and A into B. And let me show you the existing PR that we had already made and what CodeSense came back with. Okay. Now talking about the agentic architecture. So the core loop is a webhook, or you can actually install the GitHub app that we have published on Play Store. This is the CodeSense app. You can check on the GitHub's app store. And the agentic architecture for CodeSense is basically this app has a webhook tied to it. It then calls our backend server and it will enqueue that as a job, and then our three agents, hunter, coder and evaluator, will work on it and then finally provide a new PR if required, if they find bugs, and then they will solve those bugs, or otherwise they'll just tell you no PR required, or like everything has passed, everything is good. So these are the three agents and their intermediate outputs. Now I'll let Manav continue with how the agents work.
Okay. So my friend Sahaj here gave a brief description on how the agentic architecture worked. So next I'll just let you know on how we have embedded or how we have applied the LLM layer for different agents. So we have defined different states in our backend architecture such that these states have state variables, and all those state variables are basically transmitted through as the graph is flowing from the first, which is hunter here, to coder and then to evaluator. Now evaluator will get some logs from the Docker and it will revert back to coder, and coder will evaluate those logs, and if there are needed any changes, and it will give the diff or changes back to evaluator. So that is how the architecture is right now flowing, and we have used open routers LLM API hosting, like LLM hosting, and all three agents can use open router now. Hunter for the target dossier. So first of all, hunter goes ahead and returns a target dossier on what it finds in the code repo, or the difference, basically the diff that it gets from the PR. Then coder goes ahead and ties up, or it reverts back diff command basically. So it knows that to change, like what changes to put, and then it sends those through the state variables to evaluator. Evaluator then goes ahead and starts a Docker container. Like basically, there's a container running within the container itself, where it gets the diff commands from, or the diff script to apply on the repo. So first it clones the entire repo into the sandbox, which is the Docker, and then it applies the git patch. And after it has been successfully been applied, we can also see the Docker logs here. Like you can see, like Linux has been installed, and then for the current repo, Python and all other things have been set up, and then a test is run, which shows that it has been successfully run, so that the git patch has been applied and the new updates from coder has been accepted through the tests in the repo. So let me go into this a little further. So Hunter, let me just give a little in like more depth into how Hunter coder and or evaluator works. So Hunter input includes repo, PR number, event and token availability. It fetches changes from GitHub and builds a baseline dossier. If open router is enabled, then Hunter will request a stricter JSON dossier, validates it, and then applies, and then it basically reverts back dossier, like I said. Similarly, coder is also an LLM output, where open router is called and it reverts back with a patch. Then, like I explained with evaluator, that is that. And then we have the retry loop, that is if evaluator fails, it attempts again. Coder retries with evaluator feedback, and if evaluator passes, workflow exits with pass, like shown here. And after that, we can see a little bit in the observability. Let me show you that. Okay. So these are the logs. Like this is how we built it. There is a backend app that is running here. We can see there is states defined in there. There is workflow defined here, and then there is there's jobs running here. The main app is here. There is queue. There's also front end defined in this repo itself. And now after this, what happens is after basically adding the app to the repo that we want to make the PR, basically this command will be basically sent to the app, and that will be sent to the backend that we have deployed on GCP. Now we have deployed the backend and front end on GCP. So this app will send a webhook or a server sent request to the CodeSense backend that we have deployed on GCP, and then the backend will read if there is a CodeSense command in it, and then it will go ahead and deploy our 3-agent architecture on that, and it will basically send back a PR comment like this one. Like we have created a CodeSense account on GitHub, and we have basically architected this bot on GitHub itself, so you can install that. Now let me call my friend Vishwas, who will explain on how the cloud environment has been set up.
Yeah, hi, my name is Vishwas. So CodeSense runs on GCP Compute Engine, VM E2 standard 2 vCPUs, 8 gigs of RAM. The backend is fast API in Docker. The front end is React server via Nginx. Both run on the same VM, as you can see over here. Nothing is hard coded. Secrets are fetched at the deploy time. The entire deploy is just one command from a Mac, that's bash deploy. It builds the backend and front end Docker. Image is pushed up to the artifact registry. SSHs are into the VM, fetches secrets from the secret manager, pulls the new image, and restarts the container via Docker Compose. So now let me just go ahead and just show you how the deployment works. As you can see, it's fetching the secrets from the secret manager and it's authenticating. And now it's it's recreating the container as the app is already deployed. Now it's doing a health check, and there you go. The application is now deployed. I'll just show you the deployment script over here. Yeah, that's the deployment script, and these are the URL for the backend and the front end. And that's all about CodeSense and our project. Thank you.